Yeah, I should say I'm the original author of the Forgot Password cheat sheet. It's been modified over time. Yeah, I was the original author on that. That's probably my biggest contribution to OWASP, if I look back at it. So the topic today is about cross-site request forgery. Number 8 on OWASP Top 10 currently. Who knows what it's going to be in the next Top 10 next year, but we'll see. So who am I? You heard a little bit about myself. I used to be a programmer. I coded a lot back in my early career. Currently, I'm a Web Application Security SME at Qualys. What that means is I work with our customers on our web app security products, including our web app scanning, web app firewall, and malware detection products. So I enjoy working with our customers, getting feedback, and I'm able to have some influence on the product in terms of what features get developed, what do customers need, what issues are they having. So it's a pretty interesting role, and I've been at it about a little more than a year. Prior to that, I was a developer. Then I went to work for FishNet Security as a consultant. I did that for 6 years on the AppSec consulting team. Did a lot of pen testing, a lot of assessments of applications during that time. I was at Veracode for a while, solution architect, and then I was the global AppSec lead at Sabre in Southlake, Texas. Okay, so I know the abstract of my talk is all things CSRF, but I actually lied. I'm not going to explain what CSRF is. So, although I will have some demo, I'll have a demo, and I'll talk about it. I mean, if you'll see what it is in the demo for sure, but I think everybody should know what it is by now, I'm not going to talk about that. By the way, that's Congresswoman Marsha Blackburn. She had some interesting comments in her interview on CNN, something about cyberbots. I would encourage you to just maybe listen to that sometime. It's pretty interesting. Okay, so back 10 years ago, in 2006, I had just started my consulting job in January with FishNet, and I was still learning. I didn't have a security background. I was still learning about various attacks and vulnerabilities, and I learned about cross-site request forgery that year. And I was also a subscriber to Netflix. Back then, it was DVDs, right? DVDs in the mail. There was only about 5 million subscribers, and I was one of them. So I was on the site looking at DVDs, adding movies to my queue, and so forth. And I was also just looking at the URLs that were in my browser and kind of wondering, okay, let me throw this through a proxy and see what these requests look like. And interestingly enough, Netflix had no idea there was such a thing as cross-site request forgery because there was zero protection against the attacks. And so I went about contacting them to do a responsible disclosure about these problems. It took about a week to find someone, but I did get a hold of somebody. Eventually, they fixed the issues. I announced it publicly, and a lot of news organizations picked it up because it was kind of a big deal. Netflix, if you read these news articles, the spokesperson for Netflix downplays it a lot. Like, no customer data was ever at risk. This was a very obscure type of thing, right? I don't agree with that. I'll show you some of the things you could do here. But Netflix, now is completely different. They have a really advanced, top-notch security team. I've met some of those guys. They do some crazy good things now. But 10 years ago, when I found this, not the case. So what were the CSRF attacks that I found that you could do on Netflix? So they were pretty nasty. So if I were an attacker, I could use CSRF to add any movie, any DVD to your rental queue of my choice. And if user were to fall victim, they would see very strange movies that they don't know how they got there. You could even, with a GET request, you could add a movie to someone's queue very easily. Obviously, they have to be logged into Netflix. You can't just do that to any random user, but Netflix has a keep me logged in checkbox. When you log in, most everyone uses that, so pretty much everyone is always logged into Netflix. So adding a DVD was very easy with a GET request. You could also do a post request to move that DVD to the top of your queue, which is particularly nasty because usually subscribers will set up their rental queue and they'll get DVDs. This first one on their list is shipped to them, and then they ship a movie back, and the next one on their list. So if you could get a movie to the top of someone's rental queue, they'd start getting these DVDs in the mail. Like, why am I getting this movie? You can just probably use your imagination to be what kind of DVDs you could get people to have delivered to them. But that would be not necessarily like a financial harm, but more of maybe some embarrassment or some confusion by Netflix subscribers. Another one that could be used for financial gain that I found was you could change the shipping address on the account of the victim so that DVDs could start rolling into your PO box or something, and instead of the actual subscriber, so you could just keep those DVDs. But also changing your login credentials. So what I found was something really interesting back then is when you first logged into Netflix and you went to the change your password page, it didn't ask you for your current password. All right, so that's a perfectly legitimate CSRF defense to do that. But in this case, after you logged in, for a period of time, and I'm not sure why it was implemented this way, but for a period of time, you didn't have to enter your current password. Most likely it was a developer thinking, well, they just logged in. Why would I make them enter their password again? So, that's something along those lines. So obviously, if you can use cross-site request forwarding to change someone's login credentials, which is email address and password in this case, you've taken over their account. The legitimate user doesn't know their password anymore. So you've completely, as an attacker, taken over their account. You could also do CSRF to cancel someone's account if you felt the need to do that. So what did it look like? Here's a couple examples for adding a DVE to a user's rental queue. Simply in your HTML page, as an attacker, you would embed this image tag. The source of that image tag would point to netflix.com. Notice it's not HTTPS. Back then it was not. I mean, as a browsing movies sort of functionality, that was not HTTPS back then, just HTTP. So with this image tag and a subscribed or a logged in Netflix user, if they were to visit my page, the browser would try to load that image. And how would it try to load it? It would try to make that request to Netflix with these parameters, particular movie ID. And Netflix gets a request coming in. It sees valid cookies, a logged in user. It sees a request to add a particular movie to the queue, and it does it. It adds that movie to the queue. In this case, this is a SpongeBob movie ID, if anybody was curious about that. So I mentioned you could also use a post request. Well, actually, take that back. It wasn't a post request. They were both GET requests, but you had to do 2 GET requests, and you had to do them in order. So with a little bit of JavaScript, that's pretty easy to do. So here we have some JavaScript code. Initially, there's an image load right after the body tag, which is the same one you just saw. It adds the movie to the queue, but by default, it goes to the end of the user's queue. All right, so then the last line you see is a set timeout call, JavaScript call, which is set to load image to 2000. 2000 is the number of milliseconds delay before it actually calls that function. So it's a 2-second delay. I just did that to give it time for the first request to take effect. And so the movie got added. Load image to JavaScript function was called, which is up here. And so that's simply also loading a new image via JavaScript. In that case, the Netflix request to move a movie to the top looked like this. You just give it the user ID. It's a move to top action. Movie ID that you want to add, which is the same, right? And then it's from Q equals true. So so if you had this bit of code in your page as an attacker, the victim would visit this page and they would suddenly have a strange movie that they have no idea why, but it's in the top of their queue. So interestingly, about the exact same time that I discovered this problem, which was late September 2006, Jeremiah Grossman of White Hat Security had written a blog post called CSRF, the Sleeping Giant. And it's still out there today if you wanted to go read it. It's pretty interesting timing that this happened right when I found this issue. And so the question is, or the question I kind of asked myself this year, looking back on this, was it really a sleeping giant? What kind of things bad things have happened or not happened? Is it, what's the status of CSRF today? So I'm going to talk about that. So as far as trends go, how serious is cross-site request forgery? Well, it seemed to skyrocket, first of all, in 2007, because in the 2004 version of the OWASP Top 10, it was not there. Jumped up to number 5 in 2007 and also in 2010. And then the 2013 edition, it dropped to number 8. And the OWASP Top 10 team made a comment at that time that they thought maybe it was due to increased awareness of this vulnerability and also to frameworks that developers are using to write web apps. They have some built-in protection against this type of thing now. That makes perfect sense. But interestingly, when I looked at the number of published CVEs that are CSRF related, they really were peaking right about when OWASP dropped down the number to number 8. But maybe that's due to awareness. Maybe we have more people out there testing for this now, and so they're finding more vulnerabilities in software, and they're publishing the advisories, and so that's why the number of CVEs goes up. But it looks, actually, looking at the numbers, that maybe, we're not done with 2016 yet, but there's only been 75 CVEs published across request forgery related. So maybe it has peaked, and maybe it's starting to drop now. So, has the giant been slayed? Well, I don't know. Let's talk about that. So, I already talked about better awareness. So just by show of hands, who here knew about cross-site request forgery before you walked in today? All right, that's like 100%, or 99.4. So that's pretty good evidence that, maybe back in 2006, I don't think that would have been the case, right? Web development frameworks, built-in protection mechanisms. I really think this is key and the correct way to quash this vulnerability. I'll kind of go through some of the frameworks later on how they do their protection mechanisms, but if you have that protection built into your framework when you're writing a web app, it's usually a matter of just configuring the protection or adding a little bit of code to your forms here, to protect. It's not a big deal. Prior to that, if you had already written a web app and didn't build in the protection, it would have been a major rework to go back and build that protection into the code. So I think the web development frameworks, having those built-in mechanisms, has been a great benefit. And then the other one, maybe not quite as obvious, is that a lot of web apps now are using a lot of AJAX requests. A lot of these newer JavaScript frameworks are doing AJAX requests, under the covers. And those requests typically go with a custom header. The one you see most often is the X requested with, and with a value of XML HTTP request. Okay, so the reason why that's important is a custom header cannot be forged by an attacker trying to do a CSRF attack on you. The reason is that because of the same origin policy, only JavaScript code, trusted JavaScript code from the same origin can create this custom header. Now, if you have a cross-site scripting vulnerability in the web app, then all bets are off. A lot of your protection for CSRF may get blown out of the water. So let's look at some of these CSRF exploits that have happened over the years. I'm just going to have some examples here. So one of the ones that is happening now, kind of raised its head in 2008, was called drive-by farming. And so this is related to CSRF vulnerabilities in home routers and DSL modems, those kind of things. So by doing a CSRF attack on these devices, which typically have a web interface, right? But they're only accessible from internal your little home network. However, with CSRF, that doesn't matter. You can still exploit these vulnerabilities as a remote attacker, and you can do things like change the DNS settings on the router. So, in fact, this happened in both Mexico and Brazil. Those users were targeted to where the DNS settings were changed, and users and victims, when they try to go to their bank, for example, Banamex.com was part of this particular exploit that happened. Users were sent to a fake banking site, basically it's a phishing attack at this point. It looks like the legitimate site. Even the URL in the browser shows correct, but the DNS settings routed them to somewhere else. So drive-by farming is actually still happening today. It's been a consistent problem related to cross-site request forwarding. The Twitter worm in 2010, I don't know, does anyone remember this? Okay, this is my PG-13 slide. So the attack that happened was that Twitter had, for a period of time, some cross-site request forgery vulnerabilities, so that you could have this HTML code here on your page, and if anybody who was logged into Twitter visited your page, basically you would get 2 new tweets out from your account. The first one was WTF, and then the URL to the page that you're actually on, the page that hosted this code. And then another one, something about goats. This is September 26th is when it happened, 2010. And hundreds of thousands of users started to tweet this. And users were confused, but anybody who clicked on the WTF link tweet got attacked too, so they posted the same thing. So it was a worm that propagated. And Twitter shut it down that same day, but not before a whole lot of people were embarrassed. An exploit, some that have happened more recently that are more financial related, one would be eBay in 2013. Where you could use it to change the victim's address. Sound familiar? Also zip code and phone number. So this is the personal information of the user. Personal information, if you can change that stuff, it's great as an attacker because you can maybe exploit that through the forgot password functionality, because suddenly you'll know what their values are because you just set them. So you can reset their password through the forgot password mechanism and take over their account. The eBay was interesting though because it also leveraged a phone call, where one of the options to reset your password was to get a phone call and enter a 4-digit PIN. Well, you as an attacker, you could set those values. You could set the phone number and you could set the PIN both. So that was very easy. It's kind of a good attack vector. And then PayPal just this year, it was not a huge issue, but PayPal.me is a new service that they rolled out. And there was a token. They had implemented a token to protect against cross-site request forgery. However, that token wasn't being validated, so you could remove it, delete it. The request would still be honored. However, the request was just to change your profile photo. It wasn't like you could transfer money. That wasn't the vulnerability. So not a huge issue, but still, the fact that PayPal probably has a big security team in 2016 still has this issue. So, it's still happening. And then just, I went through the CVEs looking for, you can sort these by cross-site request forgery. And I kind of found a pattern or a trend. And I've already mentioned the first one, that is, all kinds of home routers and modems are vulnerable to this, the web interface for those devices. It's just the manufacturers, they just, they throw together a web UI for administering these devices, and they don't think about cross-site request forgery. So I pulled out, 20 or so CVEs, but there are many more than that out there. So that's been a historical hotbed of CSRF. And then, interestingly enough, security vendor software. So if you have some sort of a firewall or device in your network, and there's also going to be an admin UI, a web-based of some sort. And unfortunately, security vendors, and I mean, I work for one, so I don't want to say, I couldn't find Qualys in there, though. But there were a number of issues with security vendors and their security products, the admin interface having cross-site request forgery vulnerabilities, which you wouldn't think would happen, but it was a trend that you could see in the advisories that were out there. And then content management systems. So many different types out there. I started to get like spending too much time finding so many ones. I started to name individual CVEs, and so I ended up just using the big ones. I mean, Joomla, WordPress, MediaWiki, Drupal, PHP Nuke. These have all had cross-site request forgery vulnerabilities, and these are the big ones. There's probably about 100 other smaller ones that you may never have heard of, but there are CVEs related to cross-site request forgery for them as well, and I've just listed 18 or so of those. So the final verdict on this giant, has it been slayed? Was it a sleeping giant? Did it wake up? So my contention is that it never really was a giant. It was more gremlins, meaning that there were never any massive, huge, widespread, worldwide attacks due to CSRF. It's nothing like Heartbleed or Shell Shock that just everybody in the world had to jump on the vulnerability immediately. It's more that the attacks are definitely happening, but they're more highly tailored. They have to be because of the nature of the vulnerability. It depends on the web application and its functionality. So the attacks have been smaller in scope, but again, there have been a lot of them. So I don't think it was ever a giant that woke up. I think the gremlins were fed after midnight, and then they've been to everything. So you just didn't see them exfiltrate. You don't see cross-site request forgery to exfiltrate millions of records, and so forth. But it's a problem you can't ignore. But it's a smaller scope. Okay, so that kind of concludes my historical review of cross-site request forgery. Now I kind of want to dig into more technical details about detecting it in your web applications. And I'm going to fire up my demo of this here. So I have Burp, and I have my browser, and I'm going to use a web application called Perugia, however you say that. It's a purposely vulnerable web app. It's part of the OWASP Broken Web Apps project, which is a pretty cool VM you can download and fire up. It has like dozens and dozens of different broken apps with vulnerabilities you can test safely without getting in trouble. So I have that running here. So I'm going to, first of all, log in. My test user. Interesting, I didn't know that. Let me fix that. Thank you for telling me. Okay, better. So I have an application called Perugia, and I'm going to log in here. I put in the right password. Okay, so I'm logged in, and one of the things I always like to do if I was pen testing, I would go to the edit profile page. It's a great place to test for cross-site request forgery. This app is called Accounts. This is the account page. And we see a couple forms here. We see a change password, and we see an add user. So these look like great possible targets because they're actions that could benefit me as an attacker. If I wanted to take over this user's account, maybe I could change their password without them knowing it, or maybe I could add a user, and then log in as that user. So to test this, what I would do is, first of all, I would just exercise the functionality, and notice I'm routing my request through Burp, so everything is being logged there. So let me just change my password. Okay, and you notice it doesn't ask for the current password, so that's a pretty good indication that it probably is vulnerable. If it did ask for current password, I might test it to see if it actually required it. I might remove it in the request to see if it still honored the request. But in this case, it's not even asking for it. So now back over in Burp, let's look at my request. Okay, so here's my request. I'm going to send that over to Repeater. The reason I want to do that is I can just manipulate it manually to see. I don't necessarily need to do anything difficult, so that it's pretty quick and easy to test for this. So here's my request. It's a post request. There's a couple of URL parameters, and then the body of the request. You can see the password and the confirm new password parameters. So that's what the request looks like. You also see in this request there's a refer header, right? So as an attacker, or as a pen tester here, what I'm looking for is random strings that I can't reproduce in my attack on my HTML page. So the params view here looks kind of nice for that. So here's everything in terms of parameter values that are sent to the server. Obviously, we do have a randomized value here, the session ID, PHP session ID. I don't care, but I mean, that's a cookie, right? So that's going to automatically get submitted with the request. I don't have to, as an attacker, have to reproduce that value, so that's no problem. Everything else I see, URL parameters, body parameters, there's no randomized string here or token that's going to like prevent me from trying to execute this attack. So that's good. I can definitely try an attack here. The only other thing as an attacker I can't do is reproduce the refer header. All right, so I'm going to test, I need to remove the refer header on the request, all right, because if there's a check for that, then that may prevent me from exploiting it. Before I do that, though, I actually have to log in. This web app is weird. When you change your password, it logs you out, and so I need to create a new session here. Okay, now I need to grab the new session ID and paste that in my request here. Okay, so now I know my session ID is active. I'm going to remove the refer header. And I'm going to just change try to change this user's password to pass2. Okay, again, nothing in here is going to prevent me from the attack. So I click go. I get a 302 response. All right, I'm going to do follow redirection on that. I got another 302. Follow redirection again. Now I have a 200. Okay, so now let's see if my password was actually changed. Go back to the app and log out and try to log in with that pass2 password. PASS2. And there it is, I'm logged in. So I was able to change the password. I didn't have to go to the trouble of setting up an HTML file and visiting that HTML file. I mean, I know what the request looks like, and it looks like this. And so that request is a CSRF attack, and I can set that up in my HTML page very easily. No special token that I don't have. I know everything basically to do that attack. It's in the way the web app works. So in this particular web app, when you change your password, the response is a 302, say go to this page. And so you go to that page. And then in this case, there was 2 redirects. Why, I don't know. Bad programming. So I followed each one in Burp. I followed the redirect, and eventually I got the 200. Okay, meaning I'm finally. And the final 302 redirect was a logout request. So as I mentioned, when you change your password in this app, it actually ends up logging you out for some reason. But yeah, sometimes in Burp, it's important to do the follow redirection because there may be more processing that has to happen after you click the follow redirection. So that's why I was doing that. Okay, let's see here. The other thing I wanted to do was demonstrate the add user attack. So let's say your change password functionality is protected. You have to enter your current password, so you can't really attack that. But add user is a great one as well. So let me just add a test user here, just so I can see the request. I need to see the request in Burp. Okay. So here is my post request that adds my new user. Again, I'm going to drop that puppy over in Repeater, and I'm going to do the exact same thing. Essentially, I don't have to log in and get a new session ID because I'm still logged in. So in this case, so I'm going to remove the refer header because I can't mimic that. And then again, let's look at the parameters. The only randomized token here is in a cookie. So let me just, instead of test, I'm going to create a user called hacker, simulate my CSRF attack. Oops. Password hacker1. Go. There's a 302 redirect, so I'm going to follow that again. Now I got a 200. Okay, so let's see if my attack worked. Very easy. I'm going to try to log in as my new user, hacker1. Bam. Okay, so I just created a new user through a CSRF attack. All right, so that's what I do on a manual pen test. Typically is quick and easy, edit profile kind of things, see what's vulnerable. Now, there may be other functionality that's not related to editing profile. You know, the classic one you hear about is transferring money from one account to another. So that would be more of a financial application. Okay, let me go back. All right, so that was the demo. Let's talk about automated approaches. So using a dynamic scanner, how do they typically try to detect cross-site request forgery? Well, there's a couple ways. One is more of a passive test where the framework or the scanner tries to figure out which framework is being used by this web app, and then it tries to determine, you know, is the CSRF token that protects the forms, is it actually present and is it being used? Well, actually, for the passive test, it doesn't even test if it's being used. It just tests if it's there. Okay, so they're not really reliable. I mean, because one reason is that you know, JavaScript may be inserting those tokens on the fly before the request goes to the server, and a passive test isn't going to see that necessarily. So the active tests are a little bit more accurate in their reporting. So one thing that they do is check for sending requests without the referrer header or with a different referrer header, and they see if the application responds the same when a form submit happens. So that's a possibility, but that really only checks see if the referrer header check is there. Another way that scanners will do it is that they'll authenticate twice, same user, but in different sessions. So there's 2 session IDs. And then they'll swap the session ID with each other. So in other words, there'll be a form on, we'll say, session alpha, and there'll be a same form on session beta. We'll take B's session ID, make that request on with the form on alpha, and if that request is successful, most likely then that's going to be vulnerable. So, and then the vice versa on the other session. So that's a pretty effective way to do it. However, it does require an authenticated session. So the authentication mechanism, if that's not being used, some scanners won't even test for cross-site request forgery because, you know, far and away the most dangerous CSRF vulnerabilities are when you're a logged-in authenticated user. There's going to be some CSRF vulnerabilities when you're not logged in, you're just browsing a site, say like adding something to your shopping cart. You can attack somebody with CSRF and you can add something to their shopping cart. You know, how dangerous is that? I don't know. I don't think that's too dangerous. So usually the really nasty stuff is when it's an authenticated session. So the other thing I would say that the scanners are just not going to be fully aware of is the context of the form and whether or not it's really important. You may have a post request through a form that it's nothing dangerous, or it doesn't even really do any actions. I mean, you can have a post request that pulls data from the database, but it doesn't change anything. So in that scenario, you know, a scanner might report that this is a vulnerability on this form because there's no token, or we swapped sessions and it still worked. And but you know, it's pulling data, it's retrieving data, it's not changing anything. And so CSRF really requires, a successful attack really requires something to change on the server side, so the attacker can you know, use that to his advantage. Okay, I'm going to try to speed up a little bit, running out of, getting a little short on time, so I got quite a few slides here. So login CSRF. This is a really interesting one though. So who would think that if I could attack you and make you log in, is that a CSRF vulnerability? I say it is because there's scenarios that you can use this as a bad guy to your advantage. So the interesting thing is that when you attack someone with login CSRF, you're causing the victim to log in to the attacker with the attacker's credentials. So the user, the victim is logged in, but they're logged in as the attacker. So why would that be dangerous? I think the easiest way is to show an example. So I picked Groupon. Groupon is not vulnerable to this, but I wanted to use it as an illustration. If it were vulnerable to login CSRF, what could you do? So some possible scenarios are the victim does a search for products. So that goes into search history. So the victim may not realize he's logged in as the attacker. He may think he's logged in as himself. So that search history goes on the user's account, and so the attacker can see what the victim is searching for. Maybe not that big of a deal, but that's something that should be private, right? Another scenario, let's say you have something, you cause the victim to log into your account and you have put something in your shopping cart, and the victim sees that, he sees the little number 1 next to the cart. He's like, why do I have something in my cart? I don't remember adding something to my cart. So they click on that and they go to their shopping cart, but maybe there is a stored cross-site scripting attack that the attacker has left there for them on that shopping cart page. So then you've been able to attack the victim by cross-site scripting. Again, Groupon in this case would have to be vulnerable to stored cross-site scripting as well, but that's a valid scenario. And then another one would be, let's say, again, the victim is editing their profile and they're adding a credit card to their account, what they think is their account. But they add a credit card to their account, but they've actually added a credit card to the attacker's account, and now the attacker can use that to pay for stuff. So login CSRF, not immediately obvious why it's bad, but have to protect login forms as well. More about defending against CSRF. So quickly, the main defenses against cross-site request forgery are a unique token in the request, not in a cookie. It needs to be in a form, hidden form field, or a custom request header. So again, I think dev frameworks and how they've been able to implement this built-in protection has helped a lot in terms of keeping the destruction to a minimum in terms of this vulnerability. Besides the hidden form field, validating refer header is one fairly, well, not very common option actually. Token is by far the most common way to do it. But double submit cookie is another type of protection. Essentially that means that the framework, and AngularJS does this actually, you have a framework, it sets a cookie with a random token, which by itself is not protection, but also the cookie value is inserted in a custom request header. And then the application on the server side, when it gets the request, it checks, okay, does the value in my cookie match the value in my custom request header? And if they do, then you assume it's a legitimate request and not a CSRF attack. And so the automatic protection question, some frameworks automatically, just by using the framework, you're protected. All forms are going to be protected. Others, you have to actually add a little bit of code to make, and not forget to do it. So obviously the first one's better. So in terms of how the protection works in the different frameworks, ASP.NET prior to 4.5 had a view state user key. That was a value in the view state that was unique to each user, and so an attacker couldn't reproduce that. And 4.5 or later, they added a different type of mechanism called anti-CSRF token. And James Jardine has a nice blog post on that I reference here. ASP.NET MVC framework is a little bit different. You have to add a little bit of code to insert an anti-forgery token, as they call it, in each form. And then the controller methods also need a validate anti-forgery token added to the controller. These things, again, like VState user key is nice because you just have to turn it on. ASP.NET, you have to remember to do it as a developer. Struts 2 has a built-in token defense that you can turn on called the synchronizer token. Spring MVC, again, using a token, and a blog post on that is very useful. This is more for developers in the room, by the way. Ruby on Rails, again, built-in token defense. There's a protect from forgery option at the application controller level, and this is automatic protection, so you don't actually have to do anything. And our friends at Invisium have a big presence here at LASCON. Great blog post about Ruby on Rails CSRF protection. PHP, just going to kind of coast through this one. That the PHP native doesn't really have much as far as protection. You can do some special coding to make it work, but PHP frameworks do have some built-in protection. So just refer to the particular documentation, whether you're using Zend, Laravel, or Symfony, or something else. AngularJS, I talked about, uses double submit cookies. Python, the Django framework, has a way to do it. Some URL references there. Okay, I definitely didn't want to get away without talking about same-site cookie attribute. This is a new IETF standard that's been proposed. It's currently actually supported by the Chrome browser and also Opera. So there were similar solutions to this proposed in 2013, some by my college colleagues and also Mozilla. But same-site looks like it finally has some legs here. Same-site is essentially a new attribute to a cookie, like with HTTP only and secure. Now we're talking about having a same-site attribute. So this is going to be so that browsers will not submit a cookie from a cross-domain request. Show you what that looks like. If you want to add this protection, you would set same-site equals strict or same-site equals lax. Strict is probably too much because if you click a link on a page that goes to another site, no cookies from that other site will be sent. It's only going to be first site cookies in all cases. Lax is probably a better way to start, but that's even same site equals lax is going to prevent a lot of cross-site request forgery attacks. Even once all the browsers are supporting it. Like I said, only Chrome and Opera are doing it now. But I suspect, kind of like HTTP only when it came out, IE was the only browser that supported it. Eventually, everyone got on board and said, "Yeah, this makes a lot of sense. We should really support this." I think the same thing's going to happen here with same site. A couple more minutes here. Just wanted to talk about web app firewalls. So in general, I don't see CSRF having a lot of great or WAFs having a lot of great defense for cross-site request forgery. The reason is it's great at the code level, but having it a web app firewall in front is pretty tough. There's a couple ways that it's done. One is to insert, in Imperva, they try to check the refer header. They don't block anything, they just alert. And then F5's product, they try to inject a token as a hidden form field as the request goes to as the response goes to the browser. And then they check that token as it comes in from the browser. However, there's all kinds of caveats and issues about this, including this little quote from their website: "Modification of embedded URLs may have unintended side effects. If this behavior is incompatible with your application, disable CSRF protection." So it's essentially talking about heavy JavaScript apps. Heavy JavaScript apps, it's not going to work very well. It's like all the apps being written today are heavy JavaScript apps. So, one last thing about RASP. Runtime application self-protection. Kind of similar to the way WAFs work. They may have some more capabilities, but Essentially, they can inject tokens, they can do double submit cookies. But this is a very, very, it's an emerging sort of area of technology. And I actually had a lot of trouble figuring out exactly how RASP could protect against cross-site request forgery. But definitely, I think the potential is there, but until this is more widespread and being used more often, I think it's an open question. The ones I found, I had mentioned, they were related to the routers, the home routers, where CSRF was used. Like millions of emails were sent to, in Mexico and Brazil. This happened in 2 different places. Millions of emails were sent to users in Mexico and Brazil, and there's a particular router or home router that those countries use, a lot of the users. So the email had a link. No, actually, the email just had the attack embedded in the email itself to change the DNS settings of the router. And so the next time, if that was successful, the next time a victim tried to go to their bank, they got routed to a phishing site. But it would all happen at the DNS level, so they wouldn't actually see any redirection. So that was the largest scale CSRF attack that I was able to find. It was like 4.5 million users in Brazil.
Was there a dollar value?
I never saw a dollar value because it depends on how many of those victims got their DNS settings changed, how many actually went to their bank and actually entered their credentials on that fake site. And I don't think, being able to know that, I don't know if the numbers are there.
Okay, because one thing I'd like to do, and just FYI, if anyone has done this, is rank OWASP top 10 according to monetary value.
Yeah.
Yeah, thank you.
That would be interesting. Sounds challenging though.
Right.
All right. Well, thanks everybody.
Thanks.
Thanks.